Okay, types of primality. Second part by Sergio Adrian Martin. Other way to know if a number is prime is using the Wilson terms. That is the formula. C will be an integer only if n is a prime number. Now we are going to use the Theorem of Wilson in the language Python. In this case, we need to use the library math. We are defining a function named Wilson. We have an advantage that it is because the language includes the function factorial. We need to calculate the factorial of x minus 1 and use the formula and try to know if the value of c is an integer number or not. And by that way, I'm going to know if the number c is integer. For this case, the function must to return true, and otherwise it's going to return false. And here is the main part of the program. I'm going to introduce the value, convert it into an integer number, and call the function Wilson to get an answer. Now I'm going to test it. Number 3 prime. Okay. Again. So number A is composite. Twelve composite. 21. There's an error. The only explanation is the function factorial not working good. And there is other problem. For numbers big like that, and we are going to have an error because the function cannot do this calculation. Okay. Well, a way to try to get a better answer every way. This is a recursive function, and in this case I'm going to change to function fact. Well, try it again. 5, fine, okay. 10 is composite, okay. 21 is prime, no. 5 is prime, okay. No, the problem is because it's not the theorem. It's simplified language cannot process numbers too big. This time I'm going to try to use the language C# that is better for these cases. And here we have a program called Wilson. Here is the main part of the program. I show a message asking for the number. Here the number is going to use into the variable p. I'm going to need to use a function called factorial, and this function is not a part of the language. Here I have the factorial function that is almost equal like when I use the language Python. And when I use and I get the factorial number -1 and I assume 1, I need to do this division, and I am using other variable named error, where I'm going to get the residues of the division of the operation. Is r is equal to 0, that means that the answer is that the number is prime. Otherwise, the answer is going to be composite. This works better than the other program, but it cannot manage big numbers. In this case, all is okay. But there is a point where the answer is going to be wrong, and for this case 29, and that means that really the main problem is not language, and I must understand that the main problem is that the function factorial is too big for the language Python and include for the language C#. And that means that the method is not so perfect like the Eratosthenes method, okay? Or other way to express the problem is that the Eratosthenes is better for big numbers, and the Theorem of Wilson is only good for small numbers.